Oh yeah, here we go into lesson 2 of manipulation integration. What is that all about? Well, I would like to actually call it probably integration by manipulation. Remember, this whole chapter is about new ways to manipulate the integrands, your integrals, so that you can then actually integrate. And in this lesson, it's about something called integration by parts. Now, integration by parts is excellent, as I write here, for integrating products of functions. So when you have a function times a function, or where u substitution doesn't work in those situations, basically. So if u sub doesn't work, then maybe integration by parts is the way to go when you have a product. There's other instances where integration by parts works too. It also works well when you have something where the only thing you know about that function is its derivative. We'll see that down the road too. So I've written the formula up here, more on that shortly. With this formula, we have to know how to pick what our values are. So you're going to be integrating u dv, some function that's u times dv. And that's going to equal out to u times v minus the integral of v du. And that seems very foreign right now. We'll get to that in a little bit. That u value will often be a function with a derivative that gets simpler. Right? Its derivative gets simpler. Not always, but often. V, this v value, will often be a cyclical function like cosine, sine x, or e to the x, something with a nice, easy integral. Just because integration by parts is what you've most recently learned does not mean you forget about u substitution. I want to be very clear about that. Right? It's the new manipulation that we're going to use. So without further ado, let's use it. So it's the integral of u dv minus, or equals, uv minus integral v du. I had a student who used to say of minus svivdu, like that was an S, and I like that. A great student. All right, here we go. We've got x times e to the x dx. So you got to pick what u and dv are. I like to write out what I call the bank. So you got u du, here's the bank, v equals, and dv equals. Now remember, our formula is the integral of u dv equals u times v minus the integral of v du. The u value is going to be the thing whose derivative gets nicer, right? Whose function's derivative, I should say, is nicer than the original function. So u equals x, that's nice. Its derivative, du, is going to be dx, or 1 dx. It's nice, right? Because the derivative of x is 1, and then you get dx. dv, we pick dv now because, again, it's u dv. That's going to be e to the x dx. So here's u, here's dv. We want that integral to be nice there. So, well, that's not so bad. E to the x dx, the integral of that, to get from dv to v, you integrate. The integral of that is going to be e to the x. So to get from u to du, we got to differentiate. To get from dv to v, we integrate. Now we follow the formula. It's very simple. We've got that the integral of x e to the x dx is actually equal to u times v, x times e to the x, minus the integral of v du, which is e to the x dx. So we just manipulated this original integral. It is equivalent to that. That x e to the x is done. There's nothing else, no action to be taken on that. This, though, is an integral we can now take. That's equal to x e to the x minus, well, the antiderivative e to the x is e to the x plus c. That's it. Oh, it's awesome. I love integration by parts. I think it's so cool. Now, to check your answer, just to show you, you can always take the derivative of your antiderivative and see if you get back to your original thing that you're taking the integral of. So if I take the derivative of this, product rule dictates that it would be first d second, which would just be e to the x, plus the second function times the derivative of the first, minus the derivative of e to the x is just e to the x, plus the derivative of a constant is 0. So that's x e to the x plus e to the x minus e to the x. The e to the x's cancel out. That gives you 0, and we get x e to the x. It checks. That's what you originally integrated. Ah, oh, that's beautiful. All right, so what I wanted to do before we close out this first video on integration by parts is show you where integration by parts comes from. So again, we have that u and that dv function that we just looked at there, but what gives? To understand how to get to this function right here, uv minus integral v du, how to get to that manipulation, let's first take the derivative of two functions being multiplied, some functions in terms of x, u, and v. So it'd be first times the derivative of the second, so that's u times dv dx, plus the second function times the derivative of the first, v times du dx. Now here's the thing, since it's an equation, we can do the same thing to both sides. I'm going to integrate both sides, we'll do that in orange, with respect to x. Oh yeah, check out what happens. The integral of the derivative with respect to x is just, well, whatever we have, it's uv, equals. Now, when you take the integral of this with respect to x, you're going to get the integral of u dv dx plus the integral of v du dx times dx. Now, the dx's, if you will, cancel, right? So you end up with u dv, that integral, plus the integral again, these guys canceling, v du. Now, at this point, it was arbitrary, honestly. And so someone somewhere along the way decided, you know what, u dv is going to be the original function that we're going to want to manipulate. So we get uv, subtract that plus integral v du. So you get minus the integral of v du equals, oh yeah, the integral of u dv. So this then shows us that if we're given a product of something where it's some function times a differential, right, a function times that dx, then that could be equal to u times v minus integral v du. And that then sets us up to be able to manipulate this, any function in the form u dv. Isn't that beautiful? So that's integration by parts. It's a wonderful way to manipulate things. And again, it works wonderfully when you have products where u substitution doesn't work, and sometimes also where all we have is that we know how to find the derivative of a function. All right, I'll see you on the flip side in the next video, I hope. Peace.